In this lesson, we're looking at the midpoint and distance. And remember, the midpoint here is just a point that's an equal distance from two endpoints, all right? It's the one that's exactly halfway in between the 2 points, all right? Distance is obviously how far apart two things are. And we're going to do this in two different ways. First, we're going to look at this in terms of a graph, and then we're going to look at just a set of ordered pairs here. Okay, so when I look at a graph, if I'm looking at the distance and the midpoint and the distance between x and y, right here, it's very simple to see how far apart these are, and it's also very easy to count the halfway mark. So if you count how far apart these are, you get 8 units, so halfway would be 4, so the midpoint would be right here. So when we're talking about the midpoint between x and y, the midpoint is -4, 1. Okay, it's the point that's exactly halfway in between, and the distance we've already discussed. The distance was 8 this time. It's just how far apart they are. And what's nice about the graph, and especially with x and y here, is they're lined up very nicely, so I can just count from one to the other. Okay? When we look at x and z, however, now we're kind of going on a diagonal, so counting this thing is a little bit more difficult. I can't really count in a diagonal direction, but if I change this into vertical and horizontal, the directions I can count, see, I'm going down 8, and I'm going over 6, all right? So when we think about halfway, well, halfway down would be 4, would leave me here, and halfway across would be 3, would leave me here. So the midpoint is kind of a little bit of each of those. Down 4 and over 3, the midpoint would be here, and obviously I didn't draw my line very well because I missed it, okay? But the midpoint, it's really the halfway mark vertically and the halfway mark horizontally. So we can kind of see the midpoint counting halfway in each of the directions that can be counted. All right? So the midpoint for this one, now that I've labeled that, looks like a -1, 1. So again, I just took the vertical and horizontal distance and halved them the same way I did before when I was looking at the distance between x and y. So I go down halfway, I go over halfway. That brings me to the midpoint. Okay? The distance a little bit trickier, but we use the same basic things that we just talked about. If this side is 8 units long and this side is 6 units long, can you see that we have a right triangle here, which means I can use my Pythagorean theorem in order to find this. Remember, the Pythagorean theorem is a squared plus b squared equals c squared, and really what I'm looking for here, the distance, is this side. It's my hypotenuse, okay? So what I'm going to do here is I'm going to do 8 squared plus 6 squared, and that's going to equal d squared, which is the distance that I was looking for. So I find out that d squared equals 100. I take the square root of each side and find out that my distance this time is a 10. All right? So when I'm looking at a graph, I can either do a little bit of counting to come up with these, and when these things are diagonal, I can't count diagonally, so I use the directions that I can count in, vertically and horizontally. All right? And by taking the halfway mark for each of those, I still find the midpoint, and then by using the Pythagorean theorem, I can find the distance. Okay? When we're not given a graph, when we're just looking at ordered pairs, we're going to use a formula for this. And keep in mind that instead of the formula, you could just graph these each time and find the midpoint and distance from there. But here's the midpoint and distance formulas, and you should be able to get a sense as to where these things come from. The midpoint, it's the x values added together and divided by 2, the y values added together and divided by 2, and this is an ordered pair. And really, we're basically taking the average. We're finding the halfway mark for x and the halfway mark for y, and we're putting our midpoint in between. It's exactly what we did in that second example. The distance here, this one's not as obvious, but really this comes from solving our Pythagorean theorem. The Pythagorean theorem, if I have c squared equals a squared plus b squared, and I take the square root of each side, I find out that c equals the square root of a squared plus b squared. Okay? Except in this case, a and b are the lengths of the sides. Well, I find the lengths of the sides by finding the difference between the x values. And I find the length of the other side by finding the difference between the y values. So I can see that this is really my a value, this is my b value from my Pythagorean theorem. This is where the distance formula comes from. Okay? So it's still my Pythagorean theorem, but it's kind of in a different form. It's set up for ordered pairs. All right? For example, when I take a look at this guy, if I were to use my midpoint and distance formulas here, start with the midpoint. So the midpoint is just the ordered pair, and I add the x's together, so it's x sub 2 plus x sub 1, so it's 3 plus 7 divided by 2, comma, the second part of my midpoint formula is I add the y's together and divide it by 2, so y sub 2 plus y sub 1, and I divide that by 2 as well. And so essentially what's happening is I'm finding the average here, so I find out that the midpoint, and you can do this all in one shot here, the 7 plus 3 is a 10, divided by 2 is a 5. The 1 plus 5 is a 6, divided by 2 is a 3. And that's it, that's my midpoint. Alright, for finding the distance, I'm going to plug this right into the formula, and again, I'm using that x sub 2 and x sub 1 versus y sub 2 and y sub 1, so I do my distance formula equals the square root of, well, the second x value, which is 3, minus the first x value, which is 7, squared, plus the next one, the y values, 1 minus the 5 squared. And what's really nice about this formula is you can mix this up a little bit and still get the right answer. Notice 3 minus 7 is a negative 4, but 7 minus 3 is also a positive 4. Well, once we square that, it's not going to be any different. All right, so keep that in mind. As long as x is plugged in for x and y is plugged in for y, this formula should work. So what I get here is that gives me a 4 squared, which is 16. Here I get a 4 squared, which is also a 16. So what I end up with is the square root of 32. And now from here I'm going to simplify this radical. That's a 16 times 2. The square root of 16 is a 4, so it's 4 root 2. And I'm going to leave that in radical form. Okay? So there's my distance using my distance formula. And again, I could plot these and could have used my Pythagorean theorem. All right? If I look at the next one, again, my midpoint formula is essentially just taking the average. I take the x values, the negative 4 plus the 8, and divide it by 2. And again, here the order is really not that important either because it's addition, which is commutative. The next one I've got 0 plus a negative 2 divided by 2. And now I add and do a little bit of simplification. Negative 4 plus 8 is a 4 divided by 2 is a 2. 0 plus negative 2 is a negative 2 divided by 2 is a negative 1. So my midpoint is 2, negative 1. And now to find the distance, be careful when you do the distance here because those negatives and because you have subtraction within the formula, this is the place where we tend to make sign errors. All right. So with this one, I take my second x value, which is the negative 4, minus the 8 squared, plus the y value is 0 minus the negative 2 squared. And now from here, I'm just going to simplify this a little bit. Keep in mind that this is like adding the opposite. Same thing here, adding the opposite. So in that first set of parentheses, I have a negative 4 plus a negative 8, which is a negative 12. And when I square that, it gives me a positive 144. In the second set of parentheses, because I'm adding the opposite, it's 0 plus 2, which is a 2, and 2 squared is a 4. And now from here, it's just a matter of simplifying this a little bit further. I've got the square root of 148. And now I'm just going to look for perfect squares that divide evenly into the 148. And the biggest perfect square that I can think of off the top of my head is going to be a 4. Divides evenly in here, and that's going to be 4 times, let's see, 3, 2, 37. Oh yeah, and that's definitely the largest one since we have a prime number left. And then the square root of the 4 is a 2. So I find out that the distance equals 2 root 37. And that's it.